Today I'm going to be talking about translations, and this is our first day. I separate this in 2 days. And translation is when you take a point or a triangle or a square, any object, and you move it around the graph, up, down, left, right. So I'm going to show you how you do that. Now, the first thing we need to know before we do any translations is about a vector. A vector is something that tells us how to translate an object. So first of all, if we look at this vector, it has a name, and that's PQ, vector PQ, and it has a half arrow looking thing. So make sure that we have the correct notation on that. And the initial point is where we start, which is our P, and the terminal point is our end, which is our Q. And now we're going to see how many units it takes to get from P to Q. And there is a horizontal component, meaning how many units did it move horizontally from P to Q, and this is moving to the right. And then there's a vertical component of how many units it moves from P to Q vertically, and that moves up from P to Q. So if it's moving right, it's going to be positive. If it moves left, it's negative. And if it's moving up, it's positive. And if it's moving down, it's negative. So let's count these. So for the horizontal component, that's 1, 2, 3, 4, 5 units positive. And the vertical is 1, 2, 3, 4 units positive. So our horizontal component is 5 units, and our vertical component is 4 units. And now what we can do is take that information and put it into component form. And how we do that is we write it as horizontal, then our vertical. And how this looks is our horizontal value is 5. And our vertical value is 4. And so that is our component form. It's telling us to get from P to Q, we moved 5 units to the right and 4 units up. And that's sort of like a rule and instruction of how to move these points. So let's practice that. So it says name the vector and write its component form. So the vector, the name of this vector is JK. And make sure we put that kind of half arrow on top of it. And then our component form is always our horizontal, and then our vertical. Okay, so let's count our horizontal. Now from J to K, horizontally we're moving to the left. That's going to be a negative amount, and that's 1, 2, 3. And then from J to K vertically, we're moving up 2 units, and so that's positive. So our component form is going to be -3, 2. I'm not saying to get from J to K, we moved 3 units to the left and 2 units up. So now we're going to take these pieces and we're going to apply it to an actual figure. Okay, our first one says it says the vertices of triangle ABC are A, 0, 3, B, 2, 4, and C, 1, 0. Then we're going to translate, meaning move, triangle ABC using the vector 5, -1. Now down here at the bottom, right here, I've told you that our pre-image is triangle ABC. That's the image that we originally have, our pre-image. And the new image, which we just called the image, is triangle A prime, B prime, C prime. So that's our new image. And we're going to label that on our graph. So the first thing, let's graph our pre-image, triangle ABC. So A is 0, 3. B is 2, 4. Make sure we label. And then C is 1, 0. And then it's a triangle, so we can connect those dots. Now the next thing is we're translating using the vector 5, -1. Which means we're going to move this 5 units to the right, then 1 unit down. Okay, so from the point A, I'm going to count 5 units right, 1, 2, 3, 4, 5, and then 1 down. And that is our A prime. That is our image, the new one. Same thing with B. From B, we're going to count 5 units to the right. 1, 2, 3, 4, 5, and then 1 unit down. And then from C, 5 units right, and 1 down. And we can connect those dots. So that is our image. Let's write down what each of these points are, where they're located. A prime is going to be at 1, 2, 3, 4, 5, 2. B prime is going to be 1, 2, 3, 4, 5, 6, 7, 3. And C prime is located at 6, -1. All right, let's do another example. This next one says, find the component form, meaning how are we moving it horizontally and vertically, of the vector that translates P, -3, 6, to P prime, which is -4, 8. So we're figuring out how are we getting from P to P prime, and we're writing the component form, the horizontal and the vertical movement. So let's graph P first, -3, 6. And now let's graph P prime, which is a -4, 8. Now, to get from P to P prime, I go over left 1, so it's a -1, and then up 2 units. And remember, component form is horizontal then vertical, so our answer is a -1, 2, horizontal to vertical. All right, let's look at our last example. We're writing a rule for the translation of triangle RST to triangle R prime S prime T prime. Now, writing a rule is the same information that we use with component form. And we already know how to use component form, which is finding our horizontal and then vertical movement. So if we find these pieces of information, we can write a rule. And I'm going to look at the S to S prime. So how much does it move from S to S prime horizontally? And how much does it move from S to S prime vertically? So vertically is 2, and since it's going up, it's positive. And horizontally is 3, which is going to the right, so it's positive. Now we have to be really careful. If we look at the scale of our graph, it's going by 2s. So instead of 3, this is going to be 6. And instead of 2, this is going to be 4. So we have to be really careful to look at the scale of our graphs, okay? So our component form, our horizontal is 6, and our vertical is 4, okay? But to write a rule is just using the same information, but writing it in a different way. Now, what we're doing is we are moving points, and the 2 letters that we use for point is XY. So if we start off with point XY, and then we translate it, so we use an arrow, we're translating it somehow. Well, if we're moving it 6 units horizontally, that means we're taking our X values and adding 6 every time. So our rule is going to be X plus 6. And then if we're moving vertically up 4, that means we're moving all of our Y values by 4, so it's Y plus 4. And that is our rule right there.